First question, the oxidation number of cobalt NKCO carbon monoxide 4 is. So it's very simple. We know the oxidation number of potassium is +1. We are supposed to find out the oxidation number of cobalt. So that is, let's take X plus 4 into carbon monoxide ka value. So since we know carbon monoxide is a neutral ligand, so it's 0 and the overall charge is equals to 0. So we find that X is equals to -1. So oxidation number of cobalt in this compound is -1. That is option B. Moving towards the next question. Which one of the following is an inner orbital complex as well as diamagnetic in behavior? Okay, atomic number for zinc is 30, chromium is 24, cobalt is 27 and nickel is 28. So here the inner orbital complex is this cobalt. I'll explain you how. The cobalt NH3 3 plus. Oxidation number of cobalt, let's find out. That is X plus 6 into ammonia, that is a neutral ligand, so it's 0 and the overall charge is equals to +3. So therefore we find that oxidation number of cobalt in this molecule is +3. So cobalt +3 is having the electronic configuration D6. Okay, so D6 it is, this is the d orbital, 1, 2, 3, 4, 5 and the 6, d6 electron. Okay, rest 4s and 4p orbitals are empty available for this coordinating 6 ligands. Now the 6 ammonia ligand is a strong free ligand and thus they can pair this. So the pairing of electron happens and we get the configuration something like this. 1, 2, this electron come here and this electrons come here. So it is like this. And now we have this D2 available as a vacant orbital. Okay, so we can use this D2S and this P3. So hybridization in this molecule is D2sp3. Since we use d orbital of the third shell, we call it as inner orbital complex, and since all the electrons are paired, we say it as dimagnetic. So among the given option, only this molecule is the one which is there as an inner orbital complex and present as a dimagnetic behavior. So correct answer for this question is option C. Looking towards the next question, the number of moles of AgCl precipitate when excess of AgNO3 is added to 1 mole of chromium NH3 Cl2Cl is. So in this complex, chloride ion is in the form of ionic isomerism and show primary valency. When AgNO3 is added in excess, then results precipitation will occur. So correct answer for this question is option B, that is 1. Only 1 mole of a product will be formed, AgCl. Option B. Looking towards the next question, the dimagnetic species is, okay, so here we have to look for all the examples given. So nickel, we have, I'll show you. This is a d orbital, 1, 2, okay. So nickel will have this electrons d8, okay, and then this P2, DsP2 is the hybridization of NiCN. Okay, so since all the electrons are paired over here, these electrons will also be paired because they come in pair only. So this is a dimagnetic species. So correct answer for this question is option A, because dimagnetic is a one which have all the paired electron or which does not have any unpaired electron. So since here you can see all the electrons are paired in this part because of D8 configuration, the species is dimagnetic species. Looking towards the last question, in NiCl4 2-, the number of unpaired electron is. So NiCl4, oxidation number of nickel over here, let's take it as X, plus 4 minus 1 of chlorine is equals to overall charge minus 2. So it is X minus 4 equals to minus 2, and X is equals to 4 minus 2, that is equals to plus 2. Okay, so nickel oxidation state over here is plus 2. Now nickel plus 2 is having D8 configuration, and thus we have the configuration something like this. 1, 2, 3, 4, 5, 6, 7 and 8. Rest 4s orbital and 4p orbital is available for hybridization. Now the Cl is a weak field ligand and cannot form the pairing. So the hybridization of this molecule will be sp3 hybridization, and there are two unpaired electron present in this molecule. So correct answer for this question is option B, that is 2.